Yeah, guys, we're going to come back. We're going to take a look at this problem number 14. Now, 14 says find the equation of the circle that circumscribes the points here, which define the points of a right triangle. Okay, so we're going to do this like we did the other one, and kind of look at it in GeoGebra, see if we can reason out some things, and then go and do it with algebra. Okay, so here we go. Here's those 3 points plotted out for me. Now, lo and behold, there's a art tool here that I recently discovered, and which is kind of going to be interesting here. Okay, so I gotta move this guy out of the way. Okay, so let's open up more tools here. Okay, and let's look in here because um, here it is. Okay, this tool, the circle through 3 points. So, okay, we're going to do that because we can, but it's kind of cheating. But we'll show you. Okay, so select the 3 points. So, O, D, and C. Okay, there's our circle now. Okay, and now let's see. If we look at that, we can ask, okay, what is the equation of that circle? Okay, because then we would know where the center and the radius were. Okay, and there it is. It's showing it to us. Okay, so um, the equation of the circle is right there. X plus 2 quantity squared plus y minus 2 quantity squared equals 17. So it must mean then that our center is at what, 2, negative 2, 2, negative 2. Um, or I'm sorry, negative 2, 2, negative 2, 2. Well, guess what? Okay, we're going to look at this and illustrate that that's exactly where it is. So it said that this was a right triangle. And if this is a right triangle, it can be seen right here that the hypotenuse is AC. Okay? So the hypotenuse being AC, we also know a couple of things. Okay? If this is a right triangle, this is a right angle. And recently we said that a right angle intercepts a semicircle. So which means that AC would have to necessarily be the diameter of the circle as well as the hypotenuse of the triangle. With that being the case, then we can easily just go to our find our midpoint, okay, of AC, and that should be there it is, negative 2, 2, which is the center of the circle, okay. Then all we have to do is confirm that the radius is the square root of 17, so we can just measure that distance, okay, from D to A or T to C, or okay, and that's 4.1, which I bet is the square root of 17. Now let's go back and do this algebraically, okay? Go back and do this algebraically, showing you the steps that's necessary, okay? So, in this essence, then, what we find out is that, okay, um, AC is the diameter. Okay, and diameter is also the hypotenuse of the right triangle. Okay, so, and then we also found, okay, and of course, you would probably benefit by graphing these, okay, even freehand, just to confirm that AC is in fact the hypotenuse. So, I mean, you'd have to graph them and have a little bit of precision with your graph, because otherwise you're just going to be guessing at it, okay? So we also know that the midpoint of hypotenuse is equal to the center of the circumscribed circle. So in essence, it's not a whole lot different than the problem we encountered here previously, okay, which was simply, okay, we're after the equation of the circle. Of course, what goes in, what are the ingredients for the equation of the circle? The center and the radius. So in this, again, um, this is essentially the same thing. It's the exact same thing. It's just phrased a little bit differently from the beginning. Okay, these are the endpoints of the diameter, and so the midpoint of the diameter is the center of the circle, and then the distance from the center of the circle to either of the points is the radius. So that's what we're doing. We're saying AC is the diameter, so we want midpoint of AC, okay, midpoint of AC, which of course you should know by now, okay, so it's negative 6 plus 2 over 2, comma, 3 plus 1 over 2, so that's negative 6 plus 2 is 4, negative 4 over 2, which is equal to negative 2, and then 3 plus 1 over is 4 over 2, which is 2, and that confirms what we found in GeoGebra, and that's the center. That's the center of our circle. So the distance now between, well, I want to take the distance from that point that I just found, because that's the center, negative 2, 2, and actually I'd go to either A, B, C, or D, so I'm just going to pick this 2, 1, okay? Alright, so then that's our distance formula. Okay, so it's 2 minus a negative 2, that's your signs there, okay, plus 1 minus 2, 1d squared. So so this is, be careful, minus minus is plus, so that's 4 squared plus 1 minus negative 2 is negative 1 squared. Okay, negative 1 squared, of course, which is going to equal 1. So that's the square root of 16 plus 1, which is equal to square root of 17. That's 17, not 16. So lo and behold, I've got all the ingredients I need. Okay, I've got my center, and I got my radius. So I can go to my equation of the circle, which says x minus the x coordinate in the center, minus a minus 2 is plus 2. Okay, 1 squared plus y minus 2 squared, again, is equal to r squared. R is equal to square root of 17, so r squared is equal to 17. And we just confirm, in fact, that that's exactly what GeoGebra found for us. So we're pretty solid on this. So that's another good example for you, okay? And that'll do it.